Assalamu alaikum, sir. I'm Sumaiya Rahman on behalf of my group. Today our presentation topic is fire alarm using 555 timer IC. Thank you for giving me the opportunity to present my part of this presentation. We have chosen this topic from our final term topic 555 timer, and by using this we can make a fire alarm. Let's have a look on the details of our course, Digital Logic Circuit, Section D, course instructor Nafiz Ahmed Chisty sir, and our group members Asif Bin Hossain, MD Nuruddin sarder, and me, Sumaiya Rahman. Now I will discuss about fire alarm systems. With the help of a 555 timer IC, constructing a simple fire alarm system that will detect a fire and notify by sound, which will act like an alarm. Thermistors are a type of semiconductor that react like a resistor sensitive to temperature, meaning they have greater resistance than conducting materials but lower resistance than insulation. In this slide, actually we want to discuss about how thermistor works, because it is the main component of our circuit which is responsible for sensing the heat of fire. A resistance thermometer or resistance temperature detector is a device which is used to determine the temperature by measuring the resistance of pure electrical wire. This wire is referred to as a temperature sensor. If we want to measure temperature with high accuracy, RTD is the only one solution in industries. An RTD works by using a basic principle. As the temperature of a metal increases, so does the resistance to the flow of electricity. And electrical current is passed through the sensor. The resistance element is used to measure the resistance of the current being passed through it. Next slide. Now, what is 555 timer IC? The 555 timer IC is a very cheap, popular and useful precision timing device which can act as either a simple timer to generate single pulses or long time delays, or as a relaxation oscillator producing string of established waveforms of varying duty cycles from 50 to 100%. Here we can look the pin configuration in this picture of 555 timer. Let's move. Principle of methodology. The fire alarm working principle is based on thermistor used in the fire alarm circuit. This fire alarm circuit is used to identify and indicate an increase in temperature beyond certain value temperature of an enclosed area. All fire alarm systems essentially operate on the same principle. If a detector detects smoke or heat, or someone operates a break glass unit, then alarm sounders operate to warn others in the building that there may be a fire and to evacuate. A thermistor is an inexpensive and easily obtainable temperature sensitive resistor. Thermistor working principle is its resistance depends upon the temperature. When temperature changes, the resistance of the thermistor changes in a predictable way. The benefits of using a thermistor is accuracy and stability. So, why 555 timer is so popular? The 555 timer is very widely used on hobby and home brew project and in simple example circuits as found on the web. It's flexible, simple to use and works of a huge voltage range, making it's ideal for use in quick and dirty simple circuits where high precision isn't required. Next, who invented 555 timer? After so many researches, Hans R. Kamen-Zind invented 555 timer in 1971. So that's all about my part. Now I will call my next presenter, Asif Bin Hossain, to present his part.
Assalamu alaikum. My name is Asif Bin Hossain, and my previous member has already discussed about that what is 555 timer, and right now I'm going to discuss about the mechanism or the schematic of the 555 timer, that what does actually it looks like. So in this slide we can actually see that the 555 timer schematic is given here. We can see that there are exactly 8 pins of this IC. The first pin is called the ground and the 8th pin is called the VCC supply. So out of these 2 pins there are exactly 3 5 kilo ohm resistors connected in series. So and we can also see that there are 2 operational amplifiers or op-amps connected here, and there is a similarity that the negative terminal of the second op-amp and the positive terminal of the first op-amp is also connected to those 5 kilo ohm resistors. And to trigger this device we need to connect the negative of the first op-amp to the second pin of this device, which is the trigger. And there are 2 pins, which is basically the 6th and the 5th pin, threshold and the control voltage, which is connected directly to the positive of the op-amp. Now these 2 op-amps has exactly connected to a same device, which is basically flip-flop, and this flip-flop has, we know that it has a 2-bit output. The 1-bit output is connected directly to the output driver, which is again connected to the 3rd pin of this IC, which is the output, and the 2nd bit of the output of this flip-flop is connected to the 4th pin of this IC, which is the reset. So as we have to trigger this device, we needed to connect the negative terminal of the op-amp. Similarly, we have to discharge the device, and for that we have to use a transistor here. So the base of the transistor is directly connected to the flip-flop, the emitter of the transistor is connected to the 5 kilo ohm resistors, and the collector of this transistor is connected to the 7th pin of the IC, which is the discharge. That is all of this schematic of the 555 timer inside. Now we will go to the next slide and talk about the modes of 555 timer. So the 555 timer can actually operate on certainly 2 modes. There are 2 modes of the 555 timer. The first mode is the astable mode or the free running mode. Basically we know the word oscillation or oscillator, but we haven't seen maybe an electronic oscillator. Basically astable mode in 555 timer is nothing but an electronic oscillator, that it repeats a cycle or a pulse of current after a certain time. And there is the monostable or one-shot mode. That means it kind of it gives an instantaneous value, that the 555 timer functions as a one-shot. It gives a pulse of current for a specific time and then it stops. So these are the 2 modes. The first mode of the 555 timer is astable mode. If we ever see in any electronic component or any electronics that certain things are repeating after a certain time, then there is a high possibility that the 555 timer is inside there and there is the astable mode. Why is it like that? Because this is the mostly common mode used for the 555 timer, and we mostly use it for this purpose. Even in our circuit we have used the astable mode. So what is astable mode? Basically astable mode is the mode where it repeats pulses of current for a specific amount of time. So it's kind of oscillating, so it kind of repeats and repeats and repeats again and again and again, and that is how it works. So there are such devices like light emitting diodes or anything like that. So if you ever see something oscillating, there is a very high chance that the monostable mode is the second type of mode of the 555 timer IC. This is not like an oscillation that it will repeat after a certain time. In this mode, the 555 timer outputs a pulse of current for a specific amount of time and then stops. So that means it kind of gives us an instantaneous value, that it certainly gives us a pulse of current for a specific amount of time, and then it does not give, or it does then it stops. So in this mode, the 555. So in this slide we are going to talk about the circuit diagram. That means how the circuit is connected to each other of the fire alarm circuit. We can see that we have supplied 9 volt and the 555 timer, there are 8 pins. The 8th pin is connected to the VCC. The first pin is grounded. The second pin is grounded after being connected to 10 microfarad capacitor. The 6th, 3rd and the 7th pin is connected to the terminal where there are 2 resistors of 1 kilo ohm and 100 kilo ohm are in series, and the buzzers plus or the positives are connected to the 3rd pin of the triple five timer, and the negative is connected to the ground. Now we can see that the triple five timer, in triple five timer, the fourth pin is connected to a terminal where the resistor 4.7k is there, and that is connected to the emitter of the transistor, and the collector of the transistor is grounded, and the base of the transistor is connected to the terminal where there are 100k resistors, there is a thermistor, and there is the variable resistors, all are in series. So that is how the circuit actually looking like. So this is how our circuit looks like, or we have built the circuit like this. The hardware that we have implemented is a very simple fire alarm circuit, but in this slide we are going to see the simulation. This simulation is not actually the simulation of the circuit that we have implemented, but this is a simulation of a better outcome that we can do from this. That is a better circuit design according to everything if we look down. So we have simulated this so that we can actually provide a good fire alarm circuit. Anyways, there are few changes here, such as like we have provided 9 volt in our hardware, but we have provided 12 volt in this source. Actually, we have used 2 more transistors, and we have used 5 or 6 more resistors here, and there are like few changes that we can see here, and that is a very better outcome as a circuit diagram of a. In this slide, we are going to talk about that which components we have used to implement our hardwares. So first of all, 555 timer IC. We can make fire alarm by out of many things, but we are using 555 timer to make fire alarm. We need a BC547 NPN transistor. We need a thermistor. We need some bunch of resistors like 1k, 100k, 4.7k. We need a variable resistor of 1m. We need a capacitor of 10 microfarad, and we also need a battery which is of 9 volt and a buzzer. So in this slide, we are going to talk about the working concept behind our circuit. That means how this circuit is actually operating. If we look down at the right side of our slide, we will see our hardware implementation. So we can also see here that we have done the hardware implementation. Anyways, the circuit is very simple and easy to understand. As we have said earlier, that the 555 timer IC is operating in the astable mode. So with the help of this, the buzzer should produce an oscillating sound. If we don't provide any heat or fire in the thermistor, then the thermistor has the maximum resistance, and due to this the transistor remains on, but due to low voltage it does not drive the 555 timer IC, so the buzzer remains off in this situation. But if we provide some fire in the thermistor, then the resistance of the thermistor decreases, and this decreases the voltage of the base terminal of the transistor, which remains it off, and as a result the receipt pin of 555 timer IC receives the positive voltage, and it drives the buzzer and it starts beeping. So then it starts giving the indication that our fire has been converted into an alarm by the indicator of the buzzer. So that is how the circuit is actually working.
Assalamualaikum sir, this is nuruddin sarder. My part is advantage and disadvantage of 55 timer using fire alarm. Advantage: low cost, reliable, fast response, circuit can be easily constructed, high level security, easy to design, easy to modify, low power consumption, early working benefits, can easily be installed anywhere. Early warning is essential to effective fire safety because of fire can occur at any time, any place. Detection, distance, speed response, sensitivity, range of application portable. Disadvantage: false alarm, blind by thick smoke, sense near range heat only, use continuous power supply. Applications: fire alarm in office, remote LCD communicator in is. The last part is conclusion. Here 55 timer can produce very accurate and stable time delays from microseconds to hours. It can be used with supply voltage varying from 5 to 18 volt. Timer can be used in monostable mode of operation or stable mode of operation. Its various applications include wavefront generator, missing pulse detector, frequency divider, plus with modulator, generator, RAM, and generator pulse position modulator. Thus, we include from this fire alarm is used for safety and emergency purpose. This is not only used in houses but also in any type of buildings.